So, I had a very interesting situation. I gotta go to my car. I'll bring these in tomorrow because I left them in my car this morning. We were watching some March Madness this weekend, and we decided what better for March Madness than to just go to the grocery, buy a bunch of appetizers. Right. So for dinner, So by the way, some things that your parents tell you are not 100% true. When you're an adult, sometimes you can make poor choices. Like my dinner is gonna have 0 vegetables.
Oh, it's so bad. Don't tell me that.
So we had chicken wings and jalapeno poppers and mozzarella sticks because we were watching some great basketball. But I bought these jalapeno poppers and these mozzarella sticks and cooked them, and I was putting stuff into my recycling bin, and I noticed this box and this box, they're 2 different volumes, right? I had more mozzarella sticks than I got jalapeno poppers. So I noticed their volume was different, but then I noticed this one's slightly narrower. It's slightly not as deep, and it's slightly not as tall. And my buddy Dave, who I talk about all the time, was over, and he was watching me like kind of analyze this, and he's like, "What are you doing?" And I like ripped the one part off, and I was like, "I wonder." And the one box perfectly fit inside, like it had been designed this way, perfectly fit into the other box. So it got me thinking. I wonder if they did this on purpose. I wonder if there's some reason why they might have, and I don't know.
Did you just like stand there?
What?
Conspiracy theories, Mr. Hudson.
Well, not necessarily conspiracy, but like when you think about waste or like design of we have to make all these things in this factory. Well, if I'm making a box already, and then I reset the design and I just shrink everything down to like now all my dimensions will be 90% of my previous dimensions. Like 90% of the width, 90% of the length, 90% of the height. It would fit perfectly inside of it, and you get a slightly smaller box. So I don't know. I just was thinking about that over the weekend. So let's take that comparison to volume.
Looking in a box.
I mean, my food was cooking, so whatever. So what if we had 3 different packaging options? We're deciding how to package something. So we have a cylinder, a cone, ooh, and now a sphere. So we haven't dealt with spheres yet. So we're deciding how to package maybe like a new sports drink or whatever else. Like we want to be unique, right? Everybody uses cylinders. Cans, bottles, lots of things are pretty much cylinders.
I know, right?
We could be more interesting on the shelf and distribute in a cone, like rip the top off and drink out of that or something. Or you could literally design something that can't be set down. How good of a marketing campaign would it be if once you open it, you gotta drink the whole thing or else you can't set it down?
I know. My mom would love that.
So that then you might sell more, right? Or if I spill it, then I gotta buy another one. Or what if we were really crazy and sold it in a sphere, like a water balloon, sort of, whatever you're selling. So let's compare volumes. So hold on. My volume formula here is what? What's my volume formula for a prism? Abby?
Isn't the volume, I know for like triangle, 1/3?
But that's pyramid or cone.
Wouldn't it be, wait, that one, wouldn't that be pi?
So a cylinder is the same thing as a prism. The only difference is it has a circle base. So if you can't remember, think back to prisms. What was our prism volume? It was real easy.
It was 1/2.
You're trying too hard, Izzy. What is it? Volume. Check back to your notes. Check your 13.3 notes. What is volume, or maybe it was 13.2, I forget which. Volume of a prism. Guys, if you can't remember, you've not done enough practice. Volume of a prism. Shane? Now what about base, though? We're very specific when we write this. We got to use big B. Big big B times height. So if you didn't have it, go ahead and write that down. Volume of any prism, which a cylinder is a prism, is big B times H. My volume of my cone slightly different. Hayden? 1/3 the big B times H. Now, if these are both the same height and both the same base shape, well, essentially what I just said is I've now shrunk down the amount that I can fit in it by 1/3. But on the shelf, does it take up the same space? So same base shape. Circle with a radius of 3. Like we would flip this over probably if we were going to put it on the shelf. It takes up the same space. Looks just as tall, just as big, and is only 1/3 of it. Now here's the formula, and actually this was on Who Wants to Be a Millionaire. I'm not making this up. There was, I forget what level question it was, but it was talking about Pac-Man. Said if you were trying to find the volume of Pac-Man, and you knew like whatever certain dimensions or whatnot of them, the volume of a sphere is a really interesting formula. It is 4/3 pi r cubed. And I remember that by remembering the cube for volume and the 3 on the bottom. But it's not 1/3, it's 4/3 pi r cubed. So let's try this really quick. My big B on both of these will be the same thing. What shape is my big B? Grace, what shape is big B up here? For not the sphere, for these two. What's the base shape of the circle, right? So for big B, I'm going to use circle area of pi r squared. So that's going to be pi times 3 squared, which is 9 pi, which is approximately 27, but it'll come out to actually be 27. Somebody punch it in for me, please. 9 pi. What's it come out to be? 7, 8. So 27.8 approximately. And that'd be inches squared. Be careful for that label. So over at my prism, I'm actually going to drag my formula onto the object itself. For my prism, I just take that, multiply it by 6. My 27.8 times 6. Volume over here is 166.8 inches cubed. This will just be 1/3 of that. Okay, what's your question, Izzy? Because the height is 6. So yeah, the height of how distance base to base, that big H is 6. So we found big B, got to multiply it by the height. Andrew, what do you got for volume of the cone?
Well, it wasn't for the volume of the cone. I think it was for the base of the cylinder.
Okay.
It's actually 28.27.
A 28.27? Let's check our math. Sorry, I said 27, so I kind of steered that in the wrong direction. So you said 28.27? So then, was this still right?
No, it was 169.6.
69.6.
169.6.
Sorry, tweak those. My apologies. 1/3 of that, well, it's almost 170. I know 1/3 of 180 would be 60, so we're going to be 50 something. Guys, you like literally all have calculators. We're doing 169.6 divided by 3. Shane, you got it? We're okay at the 5-4. Now hold up. Prediction time.
Oh, snap.
So this sphere is 3 inches wide, 6 inches tall, which makes sense because the distance from here to here, your diameter, would be 6 inches. Will it be more volume or less volume than the cylinder? Give me hands for who has a prediction and why. You got to back it up with why. Abby?
I don't know if you might, but I think it's gonna be smaller because it doesn't have like all like I'm gonna like kind of like this might be a scary word, but the cylinder has like more edges and it has more like length to it.
Imagine
Am I
a
right?
tennis ball in a tennis can.
Oh, I see.
This, if you ever buy tennis balls, they come 3 in a can. The can's a cylinder.
My dad
The
buys
balls are
those.
spheres. So, and I'll bring this in tomorrow too. I'll put it on my list of things I need to bring in, but I might need to go to the store.
My dad has a bunch of them.
Yeah, so
I can bring
when I put a ball into a cylinder, it takes up most of the space, but not all of it. There's extras around the top edge and extra around the bottom edge. So we know this will be less than the cylinder because it is perfectly as tall, perfectly as wide. It'll fit, and there will be extra volume left over. So the question is, will the sphere have more or less volume compared to the cone? So make your own hypothesis. Which will be bigger, the cone or the sphere? Then plug all this in. I like to do radius cubed, then times pi, then times 4 divided by 3. I do the multiplication, then I do the division. So I'm going to check the math because when I don't calculate it, we've been getting into trouble. Our radius cubed, by the way, on these calculators, there's no easy cube button. So hit the caret, the up arrow right here, right beside your up and left from your 7. So hit 3, then that little arrow up, then third power. So it should look like 3 caret 3. That is 3 to the third power. That comes out to be 27, or you could have done 3 times 3 times 3. Then times pi, I hit enter. Then times 4, I hit enter. Then divided by 3, we should all hopefully get the same answer, even if you typed yours in slightly differently. If you did it in the right order, Hayden, what'd you get? Went around and just say 113.1. Because I got 113.09. I used pi button. I didn't use 3.14, I used pi button. Yeah.
My question, I don't want to go like that, but should we like circle the red part of that? And just,
That was really for the two of them. I mean, it was a
Yeah, I
working
mean-
number. You can if you want.
I mean, like, can we like circle it and like put an arrow to like the cylinder? Just so, like,
Yeah, if you want, sure.
I got
Yeah, that I used pi button. If you use just pi, you'll be slightly off, but about 113. Now, it said state the volumes in terms of pi. It said state the volumes in terms of pi. We can do that really, really easily. By dividing by pi, then we know it's the volume in terms of pi. So, all we really care to see here, the sphere, if, and this is a Math 8 thing, you'll get into this next year, but if we then analyze the surface area used, how do you think the surface areas compare for a cylinder compared to a sphere? Which one uses more surface? Andrew, what do you think?
I think the cylinder will use more surface.
Yeah, because it's got a circle bottom, a circle top, and then all that rectangle on the sides. Can I borrow your water bottle?
Yeah, sure.
This is actually ironic that you have this today. This is trying to be as close to a sphere as possible. This water bottle, without being obnoxiously round on the sides, is trying to be as close to a sphere as possible. Because they want to maximize their volume while minimizing glass used. So a sphere would technically be the best packaging you could use if all you cared about was maximum volume and the least amount of surface. But obviously, what's the problem if I make a sphere water bottle? Yeah, there's no bottom or top. Where do I open it from? How do I open it?
Spheres don't
Like-
really have that much of an opening.
So that's where the issues come in. If you cared, a sphere would be your best utilization.
Do you want me to bring in a tennis ball?
I mean, if you want to, just in case I forget, you can.
Yeah, might.
All right, move on.
Who won what?
Huh?
Oh, they said who won.
I said move on.
Oh.
Yeah. Yeah, we're gonna do that right at break extensions, whatever you want to say. So if there's athletes, you guys can go first. Like sports shuttle does not leave like right at 3:35 or 3:40. You got a little bit of time. Excuse me. Well, sometimes in life you got to make choices. So there's no other time that I can get 7th and 8th grade together. It didn't work out last week. There's too much going on this week. Problem is that I teach both grades. That's the issue because I don't have AO and lunches like normal people. So we're at a party and we get bored. All right. Sometimes birthday parties are like, it's kind of lame. So I decide to put together 2 of the party hats that we have. So I then am thinking, well, what if I like made these? What if I was going to sell these? What would the surface area be needed? Or what surface area would I need in order to do this? Well, so if I think about a party hat, what sort of shape is a party hat? Cone. Now, we have not done much with cones yet, right? Yes? No? Maybe? We've done prisms. We've done pyramids. We haven't done much with cones. So when you think about a cone, I don't have any over here. Yes, I don't. Oh, yeah, I do.
Can't.
When you think about a cone, what sort of shape is it? Like, what shapes are in it? What two-dimensional shapes? What does it do? Like, we know a prism is a shape copied, connected by rectangles. Right? A cylinder is a circle copied, connected by one giant rectangle that wraps. Justin, what do you like? What is a cone?
It's like a lot of isosceles triangles.
Ooh. So, like in theory, because we're just kind of hypothesizing here, Justin's saying I could think of it as a lot of isosceles triangles. They kind of, imagine with us, like infinitely many. Imagine thousands of isosceles triangles, all connecting from the top down to the bottom. It's a really good. I mean, if you think about a circle being an infinitely sided shape, like think about a circle as a 1,000 gone. Then make it a 10,000 gone. Then make it 100,000. Really, if you want to get weird with shape theory, a circle is a shape with infinitely many sides, or one straight line that has been curved to wrap around. Like it, there's lots of different ways you can talk about it. But if you think about a circle as having edges, check this out. Here is the lateral space. I should probably be on film for the choir people. Here's the lateral space of the cone. So here's your bottom. Here's the part that wraps. When I cut down a seam and then I open this up, now technically these little edges aren't straight. They're tiny little curves. But if I want to think about it like they're triangles, I could look at one of these guys and it looks like an isosceles triangle. And the more that I put together, I end up getting a partial circle. Could you hypothesize how much of that circle, or how we could have a formula? So, on your paper right here in the example space, I would like you to please, and I thought I had it pulled up. Maybe I closed that tab. I have one of the easy ones. I'm going to throw this onto the smartboard slide. I would like you to write this on your notes. So you want to have SA equals, like surface area equals. And you can do this above, well, depending on where you have space. So obviously your big B is pi r squared. So go ahead and write that first. Big B is pi r squared. So I don't know where that picture went. I had it open earlier. So this pi r squared, we already know about the pi r squared. We had something named differently than they do. We had something named using a different letter. So, sorry, surface area, normally pi r squared for the circular base plus half the circumference times slant height. They use h sub s. We have been using slant height. You can use whatever variable you want as long as you can remember it. What we really care about here is lateral area of a cone. The lateral area of the cone. Because in a party hat, there's no bottom. So that's for total surface area, but all we care about is lateral area. How do you find circumference? Yeah?
Radius times 2 times pi.
Yeah. So 2 times radius times pi. And then slant height, cursive L, I don't really need that in parentheses. But, okay. Anyone notice anything interesting here when I write out that formula in a different way? Because all I did was instead of writing circumference, I replaced it with how we find circumference. Anyone notice anything I could do to simplify and make things easier? Andrew?
Radius times pi times L.
Why? How? What'd you do?
Well, since it's 2 radius, I just took the 1/2 and divided by 2 by 2.
If you didn't see this, kudos to Andrew because he did.
What's that?
There's a half, like, yay, kudos, or like you did something great. You give somebody kudos to recognize them. Half of 2. Guys, you can do multiplication however you want to. Order doesn't matter. Whatever they are doesn't matter. Like terms don't matter. You can multiply anything you want. Half times 2. So really what we're saying is lateral area, and this makes it super easy, is just pi times radius times slant height. That's it. So in a cone, lateral area is just pi times radius times slant height. We aren't going to do a bunch with this. I just want you guys to be aware of it in case it pops up on your 7th grade test. This is supposed to be 8th grade standards. So I want you to be ready in case you see any cone work. Volume is the same as pyramids. 1/3 big B times H. Volume is exactly the same as pyramids. This is the only difference, is that lateral area is pi times radius times slant height. So we're going to skip the party hat one because we would then, the issue becomes, we would have to calculate this.
And then it would be like times, like, I don't know. Wait, it would be times the circumference. Since, like, it doesn't really...
We would have to, so we use Pythagorean theorem to calculate the hypotenuse. So we need this slant height. So really quickly, if we're doing a TP, we don't need a bottom. We don't need a fabric floor. So all we care about in a TP is the lateral area. So lateral area, please write down here, it's going to be pi times radius times slant height. You know that pi is 3.14. You know that the radius here is 4. Now, you don't have to know how to do this. However, stick with me while I blow your mind for a second. To calculate the unknown side here, we make a triangle. So that triangle has a bottom edge of 4, a height of 6, and we want to know this side. I use what's called the Pythagorean theorem. Orange poster. I take my one leg and square it. 4 times 4, 16. I take my other leg and square it. 6 times 6.
36.
Put those together. 16 and 36. 52. This side will be the square root. So we use that symbol that we call the radical. It'll be the square root of the sum of the squares. And your calculator has this operation for square root. So we square root 52, and we get about 7.2. So no, my slope, or my slant height, is 7.2. Well, the answer we're trying to find is lateral area. So when I do that multiplication, my lateral area is going to be the pi times the radius times that slanted edge. Anyone got it?
Was that the mind-blowing thing?
90.432. That'd be feet squared. Then, that's not actually what the question was asking me. It was asking me, how much would I spend? So if that's per square feet, we know our unit price. Last thing I would need to do, take your square feet and just multiply by 130. If you wanted to take it to the final step of figuring out that price, you multiply by 130 and find out you'd be spending over $100 for your brother. You must like your brother a lot. Yeah, $117. So to build your brother this little teepee, it's going to be $117. Please let me know if you have questions or concerns. This is the last thing we're going to do in this chapter. You don't have to be able to deal with cones. Thank you guys. Have a wonderful day.
I love my brother, but I love my money too.